Boom. Hi guys, my box with spare parts for sun inverter repair is filling up. I have now all the necessary components to fix all of my 3 broken inverters. One of them we have repaired last time, but it's not yet completely done. There's still a small problem with that one. Today's patient on the table is the SUN1000GTIL, and this one was also damaged on the AC side by a suspected surge from a lightning. So this one was on a phase where the surge was not as extreme like on the other one where a SUN2000 was hanging, and that one was really damaged very badly. On this inverter we have visual damage, but it's somehow still in a range where it should be okay. So on this board I have already done all the removal of the heatsink. I will now show you exactly what damage we have, and then we are just going to replace the components and try to fix this inverter, see what it will say after we are done. On this inverter we can see visual burn marks. So all around our transistors we have discolorations from the short circuit. We have here the gate driver. I hope you can see it. It has a hole here on its top. Here this is a thyristor like this. It's not damaged. I had to remove it just to be able to access that driver. Most probably I have to remove also this capacitor. This actually I should also remove, but it's nearly impossible because of this coil here. But you see here on the other side, here are the 2 shunts, current sensing shunts for this transistor. Those in this case I actually also need to replace. So I will try with hot air or with the soldering iron to get those out and get new in without taking the capacitor away from here. Then you can see here, this is a gate drive resistor and a pull down resistor. So it's on each side same configuration, and on each side one of the resistors is completely damaged and the other one kind of partially. So these 2 resistors will be replaced, also the other one on the other side. So that should be everything on the top side. On the back side here of the PCB we have some work because there is damage. These 2 shunt resistors, they were burned, so you could see burn marks on each of these. I have reflowed them, but they will go out and be replaced. The DC side of the inverter is perfectly fine again. The reason the DC was not powered at the time when the inverter was damaged. Here you can see some work already. This is the inverter where we had a malfunctioned power supply, a broken inductor which we have replaced about a year ago. So let's see if the second repair for this inverter will work as well. We can start with the back side. So here are 2 50 milliohm resistors. I have already reflowed these with leaded solder, so it should not be difficult anyway. Yeah, and they are already gone. These are 2 resistors, 2 watt resistors, size 2512. I got about 30 different parts here for these inverters now. These are all related to the AC side. Why so many? You will know it once we are trying to fix inverter number 3. Yeah, and we have 2 new shunt resistors. So, and the rest is job on the top side of the board. I will remove the gate driver, then we can take some measurements. Check those resistors there. So one here is a 20 ohm, should be a 20 ohm, and this one, okay, 19.9 ohm. This one is okay. The next one, 10K, is also 10K. So this side, I measured it before with the driver, is now completely normal, and before it was completely off. So that means that actually the short on the driver IC etc. have caused the resistances to deviate. Let's check the other side here. Okay, so this 20 ohm resistor has actually 18 mega ohms, so this one is damaged definitely. And the pull down resistor here, 9.9 kilo ohms, so this one is also correct. We have actually one damaged resistor only. Because I'm already replacing the 20 ohm resistor, I will do this on the other side as well. 20 ohm, size 0805. Good. Let's clean the pad here as well. And that's it. I'm a little bit afraid of taking away these two shunt resistors there. I want to add solder. That's really very bad placing here of some components. Okay, one is gone, the other one. Okay, but it seems to work somehow. The shunt resistors are in. I'll now put the two 20 ohm resistors. Next one is my driver. This is the FEN3224T as last time. Okay, the only thing missing are now our transistors. So I have my thyristor, which I have removed. This comes back in here. And then we have two new MOSFETs, which are the 20 and 60 for the 1000 watt inverter. On the 2000 watt, the 24 and 60s. And yeah, as last time, I actually want to mount the heatsink first, so that then I can just use the clamps here from the transistors, so that everything is then put nicely in place before I solder them on. So let's take the heatsinks and mount them first. Right, so the silicone tape here is damaged on this one. I have these individual silicone pads for this size of transistors, and I will just add this at this place, so that we have no problem with the insulation there. The transistors are partially clamped down and in place, so I'm going to solder them, and what we don't have to forget is also this one capacitor which we took out here. Let's put that one in quickly. Yeah, it's slowly getting dark, so yeah, I want to finish this job today because we're in the middle of the high season and I really don't have time so much to do this kind of stuff. What you want to do when there's repairs to do. I think this 1000 watt inverter is even worse than the 2000 watt. Everything is so cramped together here. I can't reach any of these bases. This is horrible. There's not much more that we can do than try. What all have we done? We have replaced the MOSFETs, the gate driver and 2 resistors, shunt resistors, and yeah, let's power the inverter up. It's connected to the AC. I am switching on the RCD and then see what happens. Buzzing. I have a blinking LED at the measurement cycle here, and I have a normal display, 0 watts and starting voltage to low. We don't have DC here. So what I can do is bring the power supply, and we can set the inverter to not listen, not look for a CT, and we can try to push power back into the grid. But otherwise it looks promising again. I have now set the LCD display to stay on, and yeah, it's still extremely dim. But you can see now 0 watts, this limiter is turned off. I'm going to turn on the power supply. It is set to maximum voltage, but now the current is limited. I will now crank up the current. And yeah, now we have maximum voltage. 2 amps is drawn. And what does the inverter say? 70 watts. Let's add more current. So maximum current 5 amps, and the inverter is pushing 200 watts into the grid. This time it looks exactly like with the SUN1000 from last time. We have a working inverter and it is pushing at least the power what our power supply, the DC power supply, can provide into the grid. So the only thing what we can now do is close the box and hang this inverter to the power wall and just see what will happen under real world conditions. Yeah guys, this one looks promising. It looks like we have the first point in our 3-parts game. It's evening, time to invert our stored DC energy from the power wall into AC again. What I want to see, of course, is that this inverter is now just ramping up to its maximum power. And that's it. Good, the last screw is set. We will replace the SUN1000 with this one for testing and then see if it will survive the night. If it does, then this repair will be a success. We are connected now and we have DC, and look now what happens. The inverter is again trying to ramp up. It is set to 800 watts output, but it is aborting. Exactly the same problem as with the other 2000 model. So I'm sure now, if I set this inverter to, let's say 300 watts or something, seems to be sort of like 1/3 of the output you can get. Let's see if this will work with 300. Cranking up, and we have 300 watt output. What can I say about this? I would really like to know what is causing this issue. Is this inverter unrepairable on the AC side? Which component is causing this phenomenon that you can only get about 1/3 of its power out once you repair the AC side when you have a short? This looks like an unsolvable problem for me, like it is now, because I have replaced all also shunt resistors. This should all be just fine. The problem now can only be solved probably by some advice from the manufacturer. I will try to contact the vendor of these devices, because he helped me out with some components for the other inverter, for the last one. Okay, boom. Yeah guys, you just heard it, we had a big boom and the AC is gone. We have a short again inside the inverter on the AC side, and yeah, the main breaker of the Powerwall phase 1 just tripped. I'm gonna reset it and remove this inverter, and then we will see what again happened to this one. But yeah, it does not look good. First of all, yeah, you saw we are always ending up with the same issue after these AC side repairs, and yeah, this time, yeah, maybe the burnt spot, which we will discover, will then help us to maybe identify a new issue, or probably it have just been the MOSFETs again, which just blew up. Okay guys, it's the next day and it's not difficult to spot what happened yesterday, from where that unpleasant sound was coming from. This here is our new MOSFET, and you can see it, it's split in two parts. The other side you can see from outside, but I think it's also damaged. Smoke came out of it. All these silicone pads are kind of burned a little bit. So yeah, what can we do with this SUN1000? But interestingly, that transistor which was completely separated here was one of the two transistors where I put a separate new silicone pad underneath. So maybe two pads cause a little bit too much insulation for the heat conductivity, and it got hotter than usual and it blew up. But there is still some major underlying problem. What can we do? I will take out those transistors and try to measure the gate signal of them using the oscilloscope. See if there is a problem with driving those transistors, and then maybe also with these inverters which had the lightning, that I will replace the thyristors here. But that circuitry actually, I think, in my understanding, is only acting like a solid state relay. So this is how the inverter is removing AC very quickly when you have like issue on the AC and it needs to activate an anti-islanding. But yeah, who knows? New components there will also probably not be wrong. Otherwise I have to check if we have good signals to the gate driver from our electronics here, and yeah, just measure more, find out what can be wrong with this device. Yeah, that's the only thing I can do at the moment. Just see if we can do some different measurements there. If the oscilloscope which I have can show us a better picture here. Okay guys, I have spent now many hours in investigating, in rebuilding. I've actually found out the reason why those two transistors blew up, and this was because it came from ordering the spare parts instead of MOSFETs. I incidentally ordered IGBTs and they did not like the situation here. So that was the difference. But now unfortunately we have again the AC side is running, we have display, but there is a new error message, and this one is called grid error. There's no further information. I looked up the internet for it. There are some cases there already. The inverter, when you look into the grid information, will show a frequency of 46 Hertz instead of my 50 here. But this is only shown like that because this seems to be the lowest value it can show. Internally the inverter thinks that there is no frequency here, but you can probe the measurement circuitry there. I did it with my small oscilloscope. I found frequency information there. It also goes to the place where it's transmitted to the control board, but still the measurement circuitry is blocking the operation of the AC side. It means that the journey is ending here, unfortunately. This SUN1000 inverter did not give us an easy repair attempt. Anyways, we also had, as you know, the other thing with the not ramping up. So this requires, I guess, a professional or probably a repair technician from the manufacturer, somebody who does know this by heart, who has schematics to these inverters. But just for us DIY amateurs, this one is unfortunately probably a no-go. Okay, so unfortunate situation. This is where the video will also end. So thank you for watching this far. We have another inverter, number 3, which we can try, but that one, yeah, it would be a miracle if it even shows something on the display. But we will see that the next time then. Okay, thank you for watching. Please like the video, comment on the down, and I see you next time.